We'll discuss question number 6. In part A, state the least value of A for which M inverse X exists. So to exist M inverse X, then Mx should be 1 to 1. So Mx should be 1 to 1 to have M inverse X. Now this is a many to 1 function. So we want to turn this many to 1 into 1 to 1 by restricting the domains. So this is the restriction is given. So you want to select which value is. So we know that if it is a quadratic graph, so if this is minimum, and let's say this value is A, X value is A, then from this value onward, the graph is 1 to 1. So you want to find this value. So this value is the minimum X value. So we'll find the minimum X value. So mx equal x square plus 4x plus 9. What is the minimum X value? This is mx. So d over dmx is, alright here, dmx over dx is 2x plus 4. dmx over dx equals 0. So 2x plus 4 equals 0. X equal minus 4 over 2 minus 2. So this value has to be greater than minus 2. So that is the A value. But you can use this one, but it is very useful completing a square because we need it to turn the function into an inverse. So mx equal x square plus 4x. Half of 4 is 2, 2 square and minus 2 square plus 9. So this will become x plus 2 square, and this is minus 4 plus 9 plus 5. So mx. Then I'm going to make x as a subject. Mx minus 5 equal x plus 2 square. So x plus 2 square equal mx minus 5. So x plus 2 equal square root mx minus 5. So this is x equal minus 2 plus mx minus 5. X goes to t inverse x, and mx goes to x. So t inverse x equal minus 2 plus x minus 5. I think part 1a answer is x equal minus 2. So this is the part 1. Part 2 is determine the equation we completed and say the domain of m inverse x. So the domain of this one, t inverse x, this is tx. Domain of t inverse mean range of tx. What is range of tx? When x equal minus 2. So we know that this value 5. Then the domain has to be x greater than or equal to 5. So this is not equal x greater than 5 because this is greater than minus 2. Then the range also greater than minus 5. So greater than minus 2, greater than 5. So this will become x greater than 5. For the reason for this one, we did the discussion on question number 5. If you are not sure why is this, please check Question number 5, the previous question, we did the discussion. Question number 7, part A. What happened to the function as x approaches 2? What happened to the function when x approaches 2? When x approaches to 2, so hx approaches to infinity, because h2 when x equal to 2 times 2 plus 1 over 2 minus 2, which is 5 over 0. So then h2 towards the infinity. Part B, x equal to is a asymptote. And part B, find h inverse 3. Now this is hx and this is h inverse x. So I want to put 3 value here, h inverse 3. When x equal 3, we will get h inverse 3. And assume this h is n nearest 3 value is as a. When you put x equal 3, so this is h inverse 3, this value a. And we know that these 3 become here, come from the range of this function. And this one become from the domain. It means if we put x equal a to this function, which is hj, should be equal to 3. So we need to find this a value. So we have two options, h a equal 3, either we want to solve, or h inverse a equal h inverse 3 equal a. But we don't know h inverse yet. Hence we have to solve this one, h a equal 3. Now we'll put h a, hx we know that 2x plus 1 over x minus 2. Then h a equal 2a plus 1 a minus 2. So the equation is h a equal 3. So 2a plus 1 a minus 2 equal 3 as h a equal 3. Now we have to solve this one. 2a plus 1 equal 3 times a minus 2 cross, and 2a plus 1 equal 3a minus 6. I'll bring to this one. So a equal 7. When you write this one, just write a not equal to 2, because x can't be 2, so a cannot be 2. Now we need to find the domain, the inverse function. So I'll take this is y equal 2x plus 1 over x minus 2. Then I want to make x as a subject, y times cross multiply, y times x minus 2 equal to x plus 1. Then yx minus 2y equal to x plus 1. I'll bring this one to here. So yx minus 2x equal to y plus 1. Then I will take x out. Y minus 2 equal to y plus 1. X equal to y plus 1 over y minus 2. So x2 y to x. So this is become y. This is 2x plus x minus 2. So this y mean uh, h inverse x. So h inverse x is 2x plus 1 x minus 2. And domain is going to be x is element of real numbers. In here also x cannot be 2. Part D, we need to find the element of the domain that get mapped to themselves by the function. So by the function which is hx, not h inverse x, get mapped to themselves. It means if you put 3, you will get 3. If you got 4, you will get 4. If you put a or b, so you will get a. So basically, what is this 3 mean? H3, and 4 mean H4. This mean HA. So HA equal A. Or I can draw the same thing. If you put 3, the relevant value is H3. If you put 4, the relevant value is H4. If you put 5, the H5. And it is going to be the same value. Same value. Them 4 and 5. So likewise A, HA. So we'll solve HA equal A. So HA mean 2A plus 1 divided by A minus 2 equal A. So this is going to be a quadratic equation. 2A plus 1 cross multiply equal A times A minus 2. So 2A plus 1 equal A square minus 2A. So everything to other side, A square minus 2A and minus 2 minus 4A minus 1 equals 0. A equal minus B plus or minus square minus 4 times A times C over 2 times 1. So you may get two answers, 2 plus or minus square root 5. So that is 2 plus 5 square root 5 and 2 minus square root 5. Basically, when you put 2 plus square root 5, this function, and this is hx function, when you put 2 plus square root 5, your answer you will get 2 plus square root 5 mapped itself. And 2 minus square root 5, if you put, you will get 2 minus square root 5. Apart from those two values, for other values, we can't put it's equal to, it is assumpted, this is going to be infinity. For other, all the infinite number of values excluding those two, it doesn't get mapped to itself. You will get a different number. So if you put 4, you will not get 4. You will get something else apart from these two numbers. Question number 8. Two function is given. We have to find n, mx. When you look at these two functions, it look like when you look at this shape, it may be inverse function. So this is inverse of this one, no vice versa. So nmx equal, we'll find nmx. So first of all, write n function, nx equal 2x plus 3. Then you have to sub instead of x, mx. So n mx, then instead of x, mx plus 3. So 2, what is mx mean then? 2x plus 3. Okay, I think I made a mistake. N is not, the n is this one. Then I want to substitute mx inside. So this is mx minus 3 over 2. Then mx, what is mx is 2x plus 3, and this minus 3 over 2. This is cancel out. So 2 to 2 cancel out. This is x. Now part B. What can you say about the function m and n? So one common thing we can check is usually whether one is inverse of other. We can check two ways. One is this one. We can take y equal to x plus 3, and we can turn this one into the 3. So this is in that case m inverse x. M inverse x equal x minus 3 over 2, which is nx. That is one answer. Or you can do the other way around. This is the best way of doing it, because nmx will check m nx. Then first of all we write m x equal 2x plus 3. Then we'll substitute nx into inside. So x instead of x, nx instead of x, nx plus 3. So 2. Now what is nx mean? Nx mean x minus 3 over 2 plus 3. So 2 to 2 cancel out. So x minus 3 plus 3, which is x. So we know that if we can give that m nx equal n mx equal x. Hence the function mx and nx are inverse each other. Question number 9. We want to show that this is function of each other. So this is as usual. So stx and t s x. We want to find whether this is equal to x or not. So we'll first of all calculate stx. So for this one, I'll write s first. Sx is 3 over x plus 1. Then I'll substitute tx. Tx means 3 tx plus 1. So 3 tx means 3 minus x over x plus 1. So now this is going to be 3 minus x plus 1. I'll multiply x over x. So then plus x over, then this is going to be cancel out, minus x plus x, 3 over x. So this is going to be 3 multiplied by x over 3, and this answer is x. So stx is x. Now we'll work out t Sx. I will write Tx first. 3 minus x over x. Then Tsx. 3 minus Sx over Sx instead of x, Sx. So 3 minus, this is 3 over x plus 1 over 3 over x plus 1. This is going to be 3x plus 1 times x plus 1 over 3 over x plus 1. So over 3 over x plus 1. Now you can see that this is 1 multiplied by x plus up and down, and I'm going to make denominator same. Then 3x plus 1 minus 3, and this will become together now x plus 1 and divide by 3 over x plus 1. So now this is going to be, we'll expand 3x plus 3 minus 3 over x plus 1 and 3 over x plus 1, which is 3 to 3 cancel out, 3x times x plus 1 divided by 3 over x plus 1. So this is 3 times a over a. Assume x over x plus 1 is a. You can see this one I can write 3x over x plus 1, 3 times x over x plus 1, which is 3a. So this is whole is a. So 3a over a to a cancel out 3. So basically when you look at this answer, you can write, this is not 3, x times 3 over x plus 1, 3x times, so then x 3 over x plus 1 is a. So this 3 over x plus 1, this x plus 1 cancel out, x is remaining. Hence you can write Tsx and Stx are equal x, hence Tx and Sx are inverse of each other. Question number 10. We need to find the inverse function. Now you can see that this is a quadratic function, 2 to 1 function. To find inverse, they restricted the domain x less than 0. So basically this is y equal x square function, and then y equal 2x square, y equal 2x square, and then you want to bring minus 3 down, something like this. So this point is going to be 0 minus 3. Now you can see either I can make this function 1 to 1, either x value greater than or 0 by doing that this restriction, no x less than 0, both works. So they selected this one, so only this part, then only this part. Now this is 1 to 1, so that's why now we can so what is the range of this one? Now range is we can see that greater than minus 3. When x equals 0, we can see that this value is minus 3. F0 is minus 3, but we can't get 0 value. Because of that, uh, minus it not equal, it has to be greater than minus 3. Range is greater than minus 3 range. So fx is a element of real numbers and fx greater than minus 3. And we'll find the inverse function now. Y equal to x square minus 3 and y plus 3 equal to x square. 2x square equal y plus 3. So x square equal y plus 3 divided by 2. X equal square root y plus 3 divided by 2. So x2, x become f inverse x and y become x. If you want, you can bring like this as well, and then you can tell x to y, y to x first. Then y equal x plus 3 over 2 square root, and then you can write this is this as f inverse x plus 3 over 2. And now x domain is going to be x is the element of real numbers and x greater than minus 3, because range become domain and it is still valid minus 3 if it doesn't define any negative values, negative roots. Now this is how usually children do. Now what is the errors? So we should do very carefully when we do this one. Usually we'll come like this and end up, but now we should have two options when we select. We can see one is this way, so other one is this way. So we pick up on this one. Now we see pick up this one, and this is y equal x, and so this is the mirror reflection. So this is minus 3, and okay, it's this distance equal to this distance, and starting from here, and it is going something like this. Now this is wrong. Why? Because this all y values are negative values. This fn is, we select this part. If you select the other part, it is going to be positive. But in this case, it's negative. So we have two options, plus and minus. And then by looking at the graph, we want to select that which one is the correct one. Since answer is f dash inverse x is negative x plus 3 over 2 and x greater than minus 3. For your information, if I take this is x to y, and I will simplify here y to x, x plus 3 over 2. Now this is usually this kind of parabola, and when we take positive one, So it will give the positive, and when we take negative one, it will give the negative part. So if this is positive, it will give positive part, and if it is negative, so it will give this part. If I further clarify, so this is y equal, this part can't be negative because it's a square root, always positive. Now here, so because of that, y values are positive in here. Now what will happen? In here, this is negative and this is positive. So negative times positive is negative. Hence, always the y values are negative in this part. Part B, there are two approach. Usually, that is, we want to show that if A and if inverse A, and we need to find the A. So basically, if A equal to A square minus 3, if I use this one, if inverse A is minus A plus 3 over 2, and then we want to make the equation 2A square minus 3 equal minus A plus 3 over 2. Now this is kind of a difficult equation. So the second best method is, now f A and f inverse A has to be same for a given A. Now when we look at the graph, so this is x, y, and um, and yeah, the graph is like this. Now this is f inverse x, and this is fx. If I get a coordinate here, this is x, f inverse x, and this coordinate, if I take x fx. Now f inverse and fx is both same in this intersection point. So that is the idea behind it. So fa equal f inverse a. For a given a, so in here the coordinate is a, and you can write fa, or you can write a f inverse a, because at that point fa and f inverse are both same. So basically we need to find the uh, coordinate of intersection point. So rather than solving those two equations, we can solve one equation, this one. So I don't want to go to square root 1, this one, and then y equal x instead of that. So this is y equal 2x cubed minus 3, and this is y equal minus square root x plus 3 over 2, and this is yx. Instead of those solving those two, I am going to solve this one and this one. So 2x cubed 2x cubed minus 3 equal x. Assume that this we need at the a point, this x value is a, x equal a, then 2a cubed minus 3 equal, because not every x place, it is a particular x place that fa become f inverse a, fx become f inverse x, that point is a when x equal a. So 2a square, sorry, 2a square minus a minus 3 equal 0. Then 2a minus 3 and a plus 1 equals 0, a equal 3 over 2, or a equal minus 1. We have two options, and we know that a is in here negative, so hence a equal minus 1.